Students, during this lecture, I'm going to explain you what machine learning is, the types of machine learning algorithms, and when you should use each of them. I particularly think that getting to know the types of machine learning algorithms is like getting to see the big picture of artificial intelligence and what is the goal of all the things that are being done in the field of artificial intelligence and machine learning, and what is the goal of all the things and why we should do this. Broadly speaking, artificial intelligence is the ability of computers to perform a task that typically requires some level of human intelligence. Machine learning is one of the type of engines that makes this possible. It uses data-driven algorithms to learn from the data to give you the answers that you need. In other words, it's software that writes software. Instead of applying a pre-built function, machine learning gains experience through repeated scene conditions and builds a model to apply in new situations. One type of machine learning that has emerged in recent years is deep learning, and it refers to the deep neural networks that are inspired from and loosely resemble the human brain. Now let me introduce you to a number of terms that is usually used in machine learning field. Terms frequently used in this lecture, apart of already mentioned, will be labeled data, classification, and regression. Labeled data is data consisting of a set of training examples, where each example is a pair consisting of an input and desired output value, also called the supervisory signal, labels, and so on. The goal of classification is to predict discrete values based on input data, while regression aims to predict continuous values, for example, home prices. The example of classification would be to classify a binary data sets, for example, to predict whether a client is going to click on the ad or not click to the ad. In email marketing, it could be a prediction model whether email is spam or not spam. In remote sensing, it could be land use land cover maps. Here is some variation of how to define the types of machine learning algorithms that commonly divided into categories according to their purpose, and the main categories are here on the slides. They are supervised learning, also semi-supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the human expert acts as a teacher where we feed the computer with the training data containing the input predictors, and we show it the correct answers, the output, and from the data, the computer should be able to learn the patterns. We are going to do quite a lot of supervised learning during this course. In unsupervised learning, here is no teacher at all. Actually, the computer might be able to teach you new things after it learns patterns in data. These algorithms are particularly useful in cases where the human expert doesn't know what to look for in the data. In the previous two types, either there are no labels for all the observations in the dataset, or labels are present for all the observations. Semi-supervised learning falls in between these two. In many practical situations, the cost to label is quite high, since it requires skilled human experts to do that. So in the absence of labels in the majority of the observations, but present in few semi-supervised algorithms, are the best candidates for the model building. These methods exploit the idea that even though the group membership of unlabeled data are unknown, this data carries important information about the group parameters. The last but not the least is reinforcement learning. It is a type of machine learning and thereby also a branch of artificial intelligence. It allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Supervised learning is most commonly used for spatial analysis, but not only for different types of machine learning based predictions in banking, email marketing, finances, medicine, and so on, so on. In supervised learning, we train the machine using data which is well labeled, which means some data is already tagged with the correct answer. A supervised learning algorithm learns from labeled training data, which helps to predict outcomes for unforeseen data. I would like to tell you an example to improve your understanding of unsupervised learning. Just consider that we have a digital image that has a variety of different animals and birds on it, like here on the right. These animals and birds needed to be matched into groups according to their type and other classification features. For a system that follows supervised learning, this whole process is a bit too simple. The procedure is extremely straightforward, as you just have to teach the computer all the details pertaining into the birds and animals. Then the algorithm will group the animals and birds according to the characteristics that you have specified. Supervised learning allows you to collect data or produce data output from the previous experience. It also helps to optimize performance criteria using previous experience. Supervised machine learning helps to solve various types of real-world computation problems. It is typically done in the context of classification when we want to map input to output labels, or regression, machine learning based supervised regression, when we want to map input to a continuous output. So classification refers to the uh, discrete outputs, classes, and regression when we need to have an output as a continuous field. In both regression and classification, the goal is to find specific relationships or structure in the input data that allow us to effectively produce correct output data. Common algorithms in supervised learning include nearest neighbor, logistic regression, decision trees, linear regression, support vector machines, artificial neural networks, random forest, and so on. Since we know the basic details portrayed in the supervised learning, it would be interesting to hop on towards unsupervised learning. The concept of unsupervised learning is not as widespread and frequently used as supervised learning. In fact, the concept has been put to use in only a limited amount of application as of yet. A type of unsupervised learning is clustering. So sometimes people don't say unsupervised learning, but say clustering, meaning unsupervised learning. I would like to tell you an example to improve your understanding also of unsupervised learning. Just consider that we have a digital image again with variety of animals, and we would like to group them according to their features. So, but for the algorithm for an unsupervised learning system has the same input data as one of the supervised counterparts that we have just had in our previous slide. In our case, digital images showing shapes in different colors. And once the unsupervised learning algorithm has the input data, so these images, it can form the information at hand. In fact, the system works by itself to recognize the problem of classification and also the difference in shapes and colors of different animals and birds. With information related to the problem at hand, the unsupervised learning system will then recognize all similar objects and group them together. The labels that it will give to these objects will be designed by the machine itself, and there is no additional input or label data that is provided. So what are the algorithms, the common unsupervised learning algorithms? Those are K-means clustering, ISO data clustering, or association.